Welcome to another video that is on linear algebra. We will now start our topic of linear algebra and we will discuss all the topics related to linear algebra. Now we will discuss some definitions in this video. What is linear transformation? Linear transformation, now we will discuss this definition of linear transformation. A linear transformation or a linear map is a function that is from Rn to Rm that satisfies the following properties. That is, t into x plus y is equal to t of x plus t of y. And the second one is t into a of x is equal to a t of x, where a is a scalar. Whenever a scalar number is multiplied with the function, the scalar and at the end the scalar number is separate. Now for any vector xy belong to Rn and any scalar a belong to R, it is simple enough to identify whether or not the given function is a linear transformation. Another useful feature of a linear transformation is a one-to-one correspondence. We have to check if we have to check a function is a linear a transformation is linear or not. We will discuss. We will check it. It's a one-to-one correspondence. If it is one-one and onto, then it is a linear transformation between matrices and linear transformation based on a matrix vector multiplication. And other definition of vector space homomorphism or linear transformation, we can say vector space homomorphism also as another name of a linear transformation. Let U of and V of F be two vector spaces over the field F, then a mapping from a U to V is called a linear transformation and homomorphism of U into V if it satisfies the following properties. That we already discussed before in the previous definition. It is the same, whereas f into alpha plus beta is equal to f of alpha plus f of beta. And similarly for the second one, f into a alpha is equal to a f of alpha for all a belong to f and alpha beta belong to u, where a is a scalar number. Or in other words, we will combine these two properties and we will write f into we can write f into a alpha plus a beta is equal to a f of alpha plus b f of beta for all a b belong to f and alpha beta belong to u, where v is the homomorphic image of u. That is the definition of vector space homomorphism, and we will also call this as a linear transformation. Now we discuss the kernel of homomorphism. What is the kernel of homomorphism? Let F be a homomorphism of a vector space of U of F into a vector space V of F. Then the set K of all the elements of U which are mapped into zero elements of V is called the kernel of homomorphism, and it is defined as K is equal to alpha belong to U, where f of alpha is equal to 0, where 0 is the vector of V. That is that's in a simple way, all the elements that mapped on is its identity element is called the kernel of homomorphism. Now let's start with range and null space of a linear transformation. What is the range and null space of a linear transformation? Let U of F and V of F be two vector spaces, and let T be a linear transformation there and from U into V. Then the image or range of T is denoted as R of T as the set of all vectors that is beta belong to V, such that, now discuss the T of alpha is equal to beta for some alpha belong to U. R of T is equal to beta belong to V, where T of alpha is equal to beta for some alpha belong to U. And null space of T denoted as N of T is the set of all vectors alpha belong to U, such that if T of alpha is equal to 0, and that is N of T is equal to alpha belong to U, T of alpha is equal to 0 belongs to V, But if we regard the linear transformation T from U into V as a vector space homomorphism of U into V, then the null space of T is also called the kernel of T. That is also mapped on the zero element identifier. It is the identity of these element vector space. Then the null space of T is also called the kernel of T. We will discuss some example in the next video. See you in the next video.